Here's the secret of the whole video. Factoring is undoing a multiplication, and there are only a few multiplications we must learn to recognize, the special products. The first is taking out a common factor, the second is a sum times a difference, and the third is a binomial squared. Every case we see is, deep down, recognizing which one was done and undoing it. Before we dive into the cases, I want to give you the full map of the journey. It's the route we'll follow to decide which method to use in each exercise. Keep this map. First, ask yourself if there's a common factor to all the terms. If there is, always take it out first. Then, count the terms you have left. If 2 are left, think of a difference of squares. If 3 are left, check whether it's a perfect square, and if not, one of the trinomials. And if 4 are left, use grouping. At the end, always check whether it can still be factored further, all the way down. That's the whole journey. Now let's go case by case. Let's start with the most basic, and also the most useful one, the common factor. I'll show it to you step by step, calmly, with everything commented on screen, so you can follow it even with the sound off. Before touching the numbers, keep this recipe, 5 steps, always the same. I'll leave it here on the side, and it will light up on its own so you always know which step we're on. 1. Find the common number. 2. Find the common letter with the smallest exponent. 3. Divide each term by that factor. 4. Write the factor outside and the results inside the parentheses. And 5. The one nobody should skip, check. Alright, we'll factor 12x cubed plus 18x squared. First, notice something the decision tree asks for. Count the terms. This polynomial has 2 terms, 12x cubed and 18x squared. The idea is to find what repeats in both, so we can pull it out. Let's start with the numbers, using the prime ladder. The rule is simple. We always try the smallest prime first, 2, and keep going with it while it divides evenly. 12 over 2, 6. 6 is still even, we keep with 2. 6 over 2, 3. 3 can no longer be divided by 2, so we move to the next prime, 3. 3 over 3, 1. So 12 is 2 times 2 times 3. We do the same with 18. 18 over 2, 9. 9 can no longer be divided by 2, so we try 3. 9 over 3, 3, and 3 over 3, 1. So 18 is 2 times 3 times 3. Now look at what repeats in both. There's a 2 and there's a 3. We multiply them and the common number is 6. Now the letter. X is in both terms, cubed in one, squared in the other. We keep the smallest exponent, x squared, because that one fits into both. Noted on your formula sheet, from repeated letters. Always take the smallest exponent. So we put the number and the letter together. The common factor is 6x squared. Keep it, because we'll divide with it. Step 3. We divide each term by 6x squared. And I'll show it 2 ways. The first is simplifying, that is, crossing out what repeats. In 12x cubed over 6x squared, the 12 and the 6 cancel, and a 2 is left on top. The x cubed and the x squared also cancel, and an x is left on top. That gives 2x. The second way is dividing directly. First we write the fraction, 18x squared over 6x squared. Now we divide part by part. 18 over 6 is 3. And x squared over x squared is x to the 0, which is 1. The x disappears. That gives 3. 2 different ways and the same result. Step 4. We build the answer. The common factor, 6x squared, goes outside, and inside the parenthesis go the quotients we just found, 2x plus 3. We get 6x squared times 2x plus 3. And notice the sign. Since both terms were positive, inside the parentheses everything stays adding with a plus sign. In other cases, if a term were negative, a minus would appear inside. This is the answer. A tip and a warning. Always check no common factor is left inside and watch out for a very typical mistake which we'll see right now in the challenge. Step 5. Check. We distribute the factor back. 6x squared times 2x. The numbers multiply. 6 times 2, 12, and since it's multiplication, we add the exponents. 2 plus 1 is 3. That's 12x cubed. Now, 6x squared times 3, 6 times 3, 18. The x squared stays the same. That's 18x squared. We got exactly back to the original, so our factoring is correct. Now let's see the common factor as a picture as an area. Picture a rectangle whose area is exactly 12x cubed plus 18x squared. If the height of the rectangle is 6x squared, our common factor, then the width must be 2x plus 3. That's why factoring is deep down, finding the sides of the rectangle. One side is the factor we take out, and the other is what stays inside the parentheses. And if we multiply the two sides, 6x squared, by 2x plus 3, we get back to the same area we started with. Now let's look at examples with more possibilities, a bit less trivial. This first one has 3 terms and also 2 different letters, A and B. First, the number, the largest that fits exactly into 8, 12, and 20 is 4. It comes from the primes they share, 2 times 2. Now the letters. From A we take the smallest exponent, A squared, and from B also the smallest, which is B to the 1. So the common factor is 4a squared B. Now we divide each term by the common factor, 4a squared b. 8a cubed b over the factor gives 2a. 12a squared b squared over the factor gives 3b. And 20a squared b over the factor gives 5. Since the first and second were positive and the third negative, inside we get 2a plus 3b minus 5. The answer is 4a squared b times 2a plus 3b minus 5. Quick check. If we multiply 4a squared b by 2a plus 3b minus 5, we get exactly back to the 3 starting terms. Now an example with a negative factor. Look, minus 8x squared minus 12x. The largest number that fits into 8 and 12 is 4, and the common letter is x. But since both terms are negative, we also take the minus out, and the factor becomes minus 4x. When dividing, watch the sign rule. Minus over minus gives plus. Minus 8x squared over minus 4x gives 2x, positive. And minus 12x over minus 4x gives 3, positive. That's why, taking the minus outside, the inside signs flip, and inside we get 2x plus 3. The answer is minus 4x times 2x plus 3. Quick check. Minus 4x times 2x plus 3 gives us back minus 8x squared minus 12x. Before we move on, try it yourself. Factor 9x plus 9. Watch out for a very common trap. I'll give you a few seconds. Let's look first at the number that repeats. It's 9. It's in 9x, and it's in the 9 on the right. So the common factor is 9. Now the letter x only appears in the first term. In the second there is none. So we don't pull out any letter, just the number 9. We divide 9x over 9 is x. And here's the trap. 9 over 9 gives 1, not 0. So when a term is the factor, a 1 stays inside. The answer is 9 times x plus 1. Great! But it can happen that there's no common factor in all the terms. We don't give up there, we group them. Let's continue with grouping. It's the common factor's best friend. When there's no common factor to all the terms, but there is one in groups, we join them in pairs and take a factor out of each group. I'll show it step by step, calmly. Before touching the numbers, keep this recipe. 6 steps, always the same. I'll leave it here on the side, and it will light up on its own. 1. Count the terms. We look for 4 terms with no common factor to all. 2. Group them in pairs. 3. Take the common factor out of each group. 4. Notice the common binomial that appears. 5. Factor out that common binomial. And 6. The one nobody should skip, check. We'll factor a times x plus a times y plus b times x plus b times y. First we count the terms. This polynomial has 4. ax, a y, bx, and by. Notice something key. No letter is in all four terms at once, so there's no common factor to all. But we don't give up. Grouping works here. Step 2. We group them in pairs. The first two, ax plus ay, in one group, and the last two, bx plus by, in another group. The idea is that inside each group there is a common factor. Step 3. And here's the magic. From the first group, ax plus a y, we take out common factor a, leaving a times x plus y. From the second group, bx plus by, we take out common factor b, leaving b times x plus y. And now look what appeared. Both groups give the same binomial, x plus y. Note that both groups must give the same binomial. If they differ, you grouped wrong or missed a sign. Steps 4 and 5. Since both groups share the binomial x plus y, we pull that common binomial out just once. X plus y outside, and inside the other parenthesis stays what's left, the two letters we pulled out, a plus b. The answer is x plus y times a plus b. Step 6. Check. We multiply each term of the first parenthesis by each of the second. X times a, x times b, y times a, and y times b. That gives us ax plus bx plus a y plus by. And if we reorder, we get exactly back to the four starting terms, so the factoring is correct. Let's see grouping as a picture as an area. Picture a big rectangle split into four little pieces with areas ax, a y, bx, and by, exactly our four terms. The width of the rectangle splits into x and y, that is, the width is x plus y, and the height splits into a and b. The height is a plus b. So the total area, which is the four terms, is width times height, x plus y, times a plus b. The same answer, now drawn. Let's see less trivial possibilities, now more briskly. The first, the plus 1 trap. From the first group, 2x cubed plus 3x squared, we take out x squared, leaving x squared times 2x plus 3. But the second group, 2x plus 3, is already the full binomial. Taking its common factor, a 1 stays inside, not 0. The common binomial is 2x plus 3, and outside we get x squared plus 1. The answer, 2x plus 3 times x squared plus 1. Quick check, 2x plus 3 times x squared plus 1 gives us back the four starting terms. The second possibility, watch the signs. We have ax minus a y minus bx plus by. From the first group we take out a, leaving a times x minus y. And here's the detail. From the second group, minus bx plus by, we take out minus b, not plus b. Taking the minus out, the inside signs flip, and we get x minus y, just like the first group. The common binomial is x minus y, and outside stays a minus b. The answer, x minus y times a minus b. Quick check, x minus y times a minus b gives us back ax minus a y minus bx plus by. Your turn. Factor by grouping 2x cubed plus 6x squared plus 5x plus 15. Mind the binomials. Both groups must give you the same one. Take a few seconds. We group in pairs. From the first group, 2x cubed plus 6x squared comes 2x squared times x plus 3. From the second group, 5x plus 15 comes 5 times x plus 3. Both groups give the same binomial, x plus 3. That's why we're on track. We pull x plus 3 out, and inside stays 2x squared plus 5. The answer, x plus 3 times 2x squared plus 5. Common factor and grouping were about pulling out a factor. Now come the cases that undo a special product, and the first one is beautiful, the difference of squares. Let's continue with the difference of squares. Here we no longer pull out a factor, now we undo a special product. It's two squares being subtracted, and there's a direct formula. I'll show it step by step, calmly. Before touching the numbers, keep this recipe, 4 steps, always the same. I'll leave it here on the side, and it will light up on its own so you always know which step we're on. 1. Check there are two terms, and that they're being subtracted. That's why it's called a difference, because a difference is a subtraction. 2. Take the root of each one. That gives us a and b. 3. Apply the formula, a plus b times a minus b. And 4. Check whether we can keep going to factor completely. We'll factor x squared minus 16. First we count. This polynomial has two terms, x squared and 16. And notice the middle sign. It's a minus, meaning the two terms are being subtracted. That's why it's called a difference of squares, because a difference is precisely a subtraction. Step 2. We check both are perfect squares and take their root. The root of x squared is x. That will be our a. And the root of 16 is 4, because 4 times 4 is 16. That will be our b. So, a is x and b is 4. Note it on your formula sheet. The root of the first square is a, and of the second is b. Step 3. We apply the formula. Remember, a squared minus b squared equals a plus b times a minus b. Since a is x and b is 4, we put them in place. In one parenthesis goes the sum, x plus 4, and in the other goes the subtraction, x minus 4. Notice carefully, there's always one parenthesis with a plus and another with a minus. This is the answer. Let's check by multiplying back. X times x is x squared, x times minus 4 gives minus 4x, 4 times x gives plus 4x, and 4 times minus 4 gives minus 16. And here's the beauty, the two middle terms, minus 4x and plus 4x, are opposites, so they cancel and vanish. That's why order and signs matter so much. One goes with a plus and the other with a minus, so the middle one goes away. We're left with x squared minus 16, the original. And since x plus 4 and x minus 4 can no longer be factored, the factoring is complete. Before moving on, an important warning, because people get this wrong a lot. The formula only works when there is a subtraction. If instead of subtraction there were an addition, like x squared plus 16, that cannot be factored over the real numbers. Remember it, a sum of squares stays put. The formula is only for the difference, for the subtraction. Let's see why it works with a picture. Picture a square with side A. Its area is a squared. Now, in one corner, we cut out a little square of side B. We remove b squared. What's left is exactly a squared minus b squared in this L shape. Now we cut the L into two pieces along this line, and we rearrange the top piece, we rotate it, and attach it to the right side of the bottom one, and we got a rectangle with the same area as before. But now its sides are the base, a plus b, and the height, a minus b. Since the area didn't change, a squared minus b squared is a plus b times a minus b. There's the formula, drawn. Let's see slightly less trivial possibilities, now more briskly. The first with a coefficient. The root of 4x squared is 2x, because 2x times 2x gives 4x squared, that's a. And the root of 25 is 5, that's b. We apply the formula 2x plus 5 times 2x minus 5. One parenthesis with a plus and another with a minus. Quick check, 2x plus 5 times 2x minus 5 gives us back 4x squared minus 25. The middle terms cancel again. The second, a double case, to factor all the way. Look, x to the fourth minus 16. X to the fourth is x squared squared, and 16 is 4 squared. So it's a difference of squares. X squared plus 4 times x squared minus 4. Now, careful. X squared plus 4 is a sum of squares, so that one stays put. But look closely. The second difference of squares is this one, x squared minus 4, and it splits again. X plus 2 times x minus 2. The complete answer joins the three factors. That's the point. We don't stop halfway. We factor until it can't be done anymore. Your turn. Factor 9x squared minus 1. Think about the root of each square, and remember that one is also a square. Take a few seconds. The root of 9x squared is 3x, because 3x times 3x gives 9x squared, that's a. And the root of 1 is 1, because 1 times 1 gives 1, that's b. So the answer is 3x plus 1 times 3x minus 1. We've seen two squares subtracting. but it can happen that there's also a term in the middle and everything is an addition. That's the perfect square trinomial. Let's continue with the perfect square trinomial. Here we no longer pull out a factor, we undo a binomial squared. There are 3 terms, and there's a very simple test to recognize it. I'll show it step by step, calmly. Before touching the numbers, keep this recipe, 5 steps, always the same. I'll leave it here on the side, and it will light up on its own so you always know which step we're on. 1. Check there are 3 terms. 2. See that the first and third are perfect squares and positive, and take their roots. That gives us a and b. 3. The middle test. The middle term must be 2 times a times b. 4. If it passes, we write the binomial squared with the sign of the middle term. And 5. The one nobody should skip, check. We'll factor 4x squared minus 12x plus 9. First we count. This polynomial has 3 terms. 4x squared minus 12x and plus 9. When there are 3 terms, the first thing we suspect is a perfect square. Let's check it. Step 2. The first and third must be perfect squares and positive, and we take their root. The root of 4x squared is 2x, because 2x times 2x gives 4x squared. That will be our a. And the root of 9 is 3, because 3 times 3 gives 9. That will be our b. So a is 2x, and b is 3. Note it on your formula sheet. The root of the first square is a, and of the third is b. Step 3. The middle test, which is the key to everything. We multiply 2 times a times b, that is 2 times 2x times 3, and that gives 12x. Now we compare it with the middle term, which is 12x. They match, so it passes the test. It's a perfect square. And notice the sign. The middle term is negative, so the binomial will take a minus. Step 4. Since it passed, we write the binomial squared. Inside goes a, 2x, then the middle sign, which was minus, and then b, 3, all squared. We get 2x minus 3, all squared. Remember, the sign of the middle term is what rules. If it were positive, it would take a plus. This is the answer. Step 5. Check. We expand the square back. The first squared, 2x squared, gives 4x squared. Minus 2 times 2x times 3 gives minus 12x. And the last squared, 3 squared, gives 9. Putting it all together, we get back to 4x squared minus 12x plus 9, the original. The factoring is correct. And where does all this come from? A binomial squared, a plus or minus b squared, always gives 3 terms, a squared, plus or minus to a b, and plus b squared. Factoring a perfect square is simply undoing that, returning the 3 terms to their squared binomial form. Let's see it with a picture with areas. Picture a big square with side a plus b. Its area is a plus b squared. Splitting the side into a and b, the square is divided into 4 pieces. One is the big square of area squared. 2 are equal rectangles, each of area a times b. Together they are 2ab, exactly the middle term. And the last is the little square of area b squared. Adding the 4 pieces, a squared plus 2ab plus b squared, we get the full square again. That's why it's a perfect square. Now let's see other possibilities, a bit more briskly. The first, quite simple, x squared plus 6x plus 9. The root of x squared is x, and the root of 9 is 3. The middle test, 2 times x times 3 gives 6x, exactly the middle term. Since everything is adding, the binomial takes a plus, x plus 3 squared. Quick check, x plus 3 squared gives us back x squared plus 6x plus 9. The second, with a coefficient and a minus, 9x squared minus 24x plus 16. The root of 9x squared is 3x, and the root of 16 is 4. The test, 2 times 3x times 4, gives 24x, which matches the middle term. And since the middle term is negative, the binomial takes a minus, 3x minus 4 squared. Check, 3x minus 4 squared gives us back 9x squared minus 24x plus 16. But watch out for a very common mistake. Not every trinomial with square ends is a perfect square. You must verify the middle. Look at this, x squared plus 7x plus 9. The first and last are squares, their roots are x and 3. But the middle test gives 2 times x times 3, that is 6x, and the middle term is 7x. 6x is not equal to 7x, so it doesn't pass. This is not a perfect square. It's a different kind of trinomial, and it factors differently. Your turn. Let's see if x squared plus 10x plus 25 is a perfect square, and if it is, factor it. Take a few seconds. The roots are x and 5, and the middle test gives 2 times x times 5, which is 10x, the middle term. It passes. Since everything is adding, the answer is x plus 5 squared. But it can happen that a trinomial doesn't pass the middle term test. Then it's a different kind of trinomial, and we factor it differently. Let's continue with another 3-term trinomial, but of a different kind. When the leading number is 1, there's a super fast method, finding 2 numbers. I'll show it step by step, calmly. Before touching the numbers, keep this recipe, 5 steps, always the same. I'll leave it here on the side, and it will light up on its own so you always know which step we're on. 1. Check there are 3 terms, and the leading number is a 1. 2. Find 2 numbers that multiplied, give the right-hand term, c, and that added, give the middle coefficient, b. 3. Use the sign rules to know which sign each number takes. 4. Write the 2 parentheses, x plus the first number, times x plus the second. And 5. The one nobody should skip, check. We'll factor x squared minus x minus 6. First we count. This polynomial has 3 terms, x squared minus x and minus 6. And notice something important. In front, multiplying x squared, there's an invisible 1. That's why this is the case x squared plus bx plus c. Here the middle coefficient b is minus 1, and the right-hand term c is minus 6. Step 2, and it's the heart of the method. We look for 2 numbers that multiplied, give minus 6, and that added, give minus 1. Let's try the pairs that multiply to minus 6. 1 and minus 6, they multiply to minus 6, but add to minus 5. Minus 1 and 6, they add to 5. 2 and minus 3, they multiply to minus 6, and added they give minus 1. Up to that. Minus 2 and 3 also multiply to minus 6, but add to 1, so it doesn't work. Our 2 numbers are minus 3 and plus 2. Step 3, and with this you'll almost never get it wrong, the sign rules. If c is positive, both numbers take the same sign, and that sign is the sign of b. But if c is negative, the 2 numbers take different signs, and the one with larger absolute value takes the sign of b. In our case, c is minus 6, which is negative, so the signs are different, and since b is minus 1, the larger number, 3, takes a minus. That's why we get minus 3 and plus 2. Note it, first decide the signs with c and b, and only then look for the numbers. Step 4. The 2 numbers go straight into the parentheses. We open the first parenthesis with x and put the first number, minus 3. And we open the second parenthesis, also with x, and put the second number, plus 2. We get x minus 3 times x plus 2. This is the answer. Step 5. Check. We multiply the 2 parentheses back, term by term. X times x gives x squared. X times plus 2 gives plus 2x. Minus 3 times x gives minus 3x. And minus 3 times plus 2 gives minus 6. Look at the middle term, plus 2x, minus 3x gives minus x, exactly the middle of the original. Putting it all together, we get back to x squared, minus x, minus 6, the original. The factoring is correct. Let's see it with a picture with areas. Picture a rectangle with sides x plus m and x plus n. Its area is x plus m times x plus n. Splitting each side into x and the number, the rectangle is divided into 4 pieces. The first is a big square of area x squared. The 2 on the sides are rectangles, one of area n times x, and another of area m times x. Together they are m plus n times x, exactly the middle term. And the last is the little rectangle of area m times n. Adding the four pieces, we get x squared plus n times x plus m times n. That's why the two numbers add to b and multiply to c. Now let's see other possibilities, a bit more briskly. The first, all adding, x squared plus 5x plus 6. Since c is positive, both numbers take the same sign, and since b is positive, both are plus. We look for 2 that multiply to 6 and add to 5. They are 2 and 3. So we get x plus 2 times x plus 3. Quick check, x plus 2 times x plus 3 gives us back x squared plus 5x plus 6. The second, with a minus in the middle, x squared minus 7x plus 12. C, 12 is positive, so same sign, and b, minus 7 is negative, so both numbers take a minus. Two negatives that multiply to 12 and add to minus 7, they are minus 3 and minus 4. So we get x minus 3 times x minus 4. Check, x minus 3 times x minus 4 gives us back x squared minus 7x plus 12. But watch out for something very important. This method works only when two integers with that sum and product exist. Look at this, x squared plus x plus 1. We need two integers that multiply to 1 and add to 1. The only integer pairs that multiply to 1 are 1 and 1, which add to 2, or minus 1 and minus 1, which add to minus 2. None adds to 1, so this trinomial doesn't factor over the integers. It's not always possible, and it's fine to recognize that. U-turn. Factor x squared plus 2x minus 15. Think which two numbers multiply to minus 15 and add to 2. Take a few seconds. Since c is minus 15, which is negative, the signs are different. And since b is plus 2, the larger number, 5, takes a plus. We look. 5 times minus 3 gives minus 15, and 5 plus minus 3 gives 2. So the answer is x plus 5 times x minus 3. And we reach the last case, the most feared one. We still need to see what we do when the leading number is not 1. And we reach the last case. When the leading number is no longer a 1, we use a method with its own name, the A times C method. I'll show it to you step by step, calmly, and today we will understand why it works. Before touching the numbers, keep the recipe for this case, 6 steps, and I'll leave it here on the side so you always know which step we're on. 1. Check there are 3 terms, and the leading number is no longer a 1, but a. 2. Multiply a times c, that is, the front one by the last one. 3. Find 2 numbers that multiply to a times c, and add to b. 4. Split the middle term using those 2 numbers. 5. Group, just like in case 2, and take out the common binomial. And 6. The one nobody should skip, check. We'll factor 3x squared minus 5x minus 2. Again we count. This polynomial has 3 terms. 3x squared minus 5x and minus 2. But look at the difference from the previous case. In front, multiplying x squared, there's no longer a 1, there's a 3. That front number is a. That's why this is the case ax squared plus bx plus c. Here is 3, b is minus 5, and c is minus 2. Step 2, and here's the method's name, we multiply a times c. Let's see what a times c is, so we don't take it for granted. It's the front number, a, multiplied by the last number, c. In our case, a is 3 and c is minus 2, so a times c is 3 times minus 2, which gives minus 6. That minus 6 is the key number we'll use in the next step. Step 3, and it's the heart of the method. We look for 2 numbers that, multiplied, give a times c that is minus 6, and that, added, give b that is minus 5. Let's try the pairs that multiply to minus 6. 1 and minus 6, they multiply to minus 6, and added they give minus 5. That's minus 1 and 6 add to 5. 2 and minus 3 add to minus 1. Minus 2 and 3 add to 1. Our 2 numbers are minus 6 and plus 1. One caveat, keep it in mind. This method gives you the integer factorization only if those 2 numbers exist. If they don't appear, that trinomial doesn't factor over the integers. Step 4, and here's the why, so it isn't magic. Those two numbers are the pieces the middle term splits into. Think about it. If the answer is px plus q times rx plus s, the two middle terms multiply pr by qs, which is exactly a times c. That's why their product is a times c, and their sum is b. So we split minus 5x into minus 6x plus 1x. And we rewrite the trinomial with four terms, 3x squared minus 6x plus 1x minus 2. Step 5. We group in pairs, just like we learned in case 2, so I won't repeat it here, I just use it. From the first group, 3x squared minus 6x, we take out the common factor 3x, and we're left with 3x times x minus 2. From the second group, 1x minus 2, we take out the 1, and we're left with 1 times x minus 2. Look, in both groups the same binomial appeared, x minus 2. That's the common binomial. We take it out just once, and we get x minus 2 times 3x plus 1. This is the answer. Step 6, check, which nobody skips. We multiply the two parentheses back term by term. X times 3x gives 3x squared. X times plus 1 gives plus 1x. Minus 2 times 3x gives minus 6x. And minus 2 times plus 1 gives minus 2. Look at the middle term, plus 1x minus 6x gives minus 5x, exactly the middle of the original. Putting it all together, we return to 3x squared minus 5x minus 2, the original. The factoring is correct. Now let's see with areas why the A times C method works. With a positive example to see it very clearly, 2x squared plus 7x plus 3. Picture a rectangle whose area is the whole trinomial. The bottom side is 2x plus 1 and the left side is x plus 3. The top pieces are two big squares of area x squared. There's A, which is 2x squared. The side pieces add up to 7 rectangles of area x. There's B, 7x. And the little corner rectangle is 3 units. There's C, which is 3. And the nice part, the sides of the rectangle are exactly the two factors 2x plus 1 times x plus 3. Now let's see other possibilities, more briskly. Let's go back to the one we drew, but now with the method 2x squared plus 7x plus 3. A times C is 2 times 3, 6. Two numbers that multiplied is 6 and add to 7. They are 6 and 1. We split 7x into 6x plus 1x and group 2x times x plus 3 plus 1 times x plus 3. The answer is x plus 3 times 2x plus 1. Quick check, x plus 3 times 2x plus 1 gives us back 2x squared plus 7x plus 3. The second, with bigger numbers, 6x squared plus 11x plus 4. A times C is 6 times 4, 24. Two numbers that multiply to 24 and add to 11. They are 8 and 3. We split 11x into 8x plus 3x and group 2x times 3x plus 4 plus 1 times 3x plus 4. The answer is 3x plus 4 times 2x plus 1. Check, 3x plus 4 times 2x plus 1 gives us back 6x squared plus 11x plus 4. Your turn with the last case. Factor 2x squared plus 5x plus 2. Remember, first a times C, then the two numbers, and then split and group. Take a few seconds. Let's do the solution. A times C is 2 times 2, 4. Two numbers that multiply to 4 and add to 5. They are 4 and 1. We split 5x into 4x plus 1x and group 2x times x plus 2 plus 1 times x plus 2. The answer is x plus 2 times 2x plus 1. You now have all 6 tools. The most important thing is left, knowing which one to use and in what order. That's what the decision tree is for. We already know the 6 cases separately. Now we'll mix them in exercises that level up, some with fractions. This is where the map from the start becomes your best friend. Let's start with one that combines 2 cases. Let's factor 2x squared minus 8. Step 1, the 2 is a common factor, so we pull it out, and inside we get x squared minus 4. Step 2. That inside part is a difference of squares, x plus 2 times x minus 2. The full result is 2 times x plus 2 times x minus 2. See how one case led to the other. Now try it yourself. Factor all the way 3x cubed plus 6x squared plus 3x. I'll give you a few seconds. Alright, let's see. 3x cubed plus 6x squared plus 3x. Step 1, there's a common factor, 3x. We get 3x times x squared plus 2x plus 1. Step 2, inside are 3 terms, and that trinomial is a perfect square, x plus 1 squared. The full result is 3x times x plus 1 squared. Let's go up a bit. Now with fractions. Let's factor x squared over 9 minus 1. It looks odd, but it's the same difference of squares. Notice x squared over 9 is x over 3 squared, and the 1 is 1 squared, so it's a sum times a difference, x over 3 plus 1 times x over 3 minus 1. That's the answer. The fraction doesn't change the method, just the looks. And now an algebraic fraction to simplify it. We have x squared minus 4 over x squared plus 4x plus 4. The trick is to factor top and bottom. On top, x squared minus 4 is x plus 2 times x minus 2. And on the bottom, that trinomial is a perfect square, x plus 2 times x plus 2. We rewrite the fraction already factored. And here's the nice part, the factor x plus 2 is on top and bottom, so it cancels. We're left with x minus 2 over x plus 2. And to close, the big challenge. Factor all the way, x cubed plus x squared minus 4x minus 4. Several cases come together here, so take your time. Let's take it slow. There are 4 terms, so we group in pairs. Step 1, on one side, x cubed plus x squared, on the other, minus 4x minus 4. Step 2, I take the common factor out of each group. In the first, x squared times x plus 1. In the second, minus 4 times x plus 1. Step 3, the common binomial appears, x plus 1, so we get x plus 1 times x squared minus 4. But watch out, we're not done yet. That x squared minus 4 is a difference of squares, x plus 2 times x minus 2. So the full result is x plus 1 times x plus 2 times x minus 2. That's factoring all the way, mixing 3 techniques. And now, with all of this in hand, let's return to the promise from the start, that equation I asked you to keep. Here it is, x squared minus 9 equals 0. X squared minus 9 is a difference of squares, so it's x plus 3 times x minus 3 equals 0. And here's the key, if 2 things multiplied give 0, one of them must be 0. So either x plus 3 is 0 and x is minus 3, or x minus 3 is 0 and x is 3. We solved the equation by factoring in our head. That's the promise fulfilled. Let's recap. These are the 6 cases, and they're all the same idea. Recognize which special product was done, and undo it. Common factor, grouping, difference of squares, perfect square, and the 2 trinomials. With the decision tree, you now know which to use and when. If this class helped you, subscribe and ring the bell, so the next cases reach you. Practice a lot, because factoring is learned by factoring. See you!